All right, 7.2, we go to another conic section. Ellipses were 7.1. This one is hyperbolas. So hyperbolas look like this. Again, we want to deal with what is the standard form of a hyperbola. Now this will look similar to the ellipses we were just looking at, except notice here, one fraction is positive and one fraction is negative. Right? That's, sometimes the x fraction will be positive or negative, sometimes the y fraction will be positive or negative. So what this tells us is when it's in this form, when the x fraction is positive, and notice here also the a value is always going to go under the positive fraction. So that's another difference with ellipses. The a value always goes under the positive fraction. In this case, the x fraction is positive, so that tells us that our hyperbola here, and the shape of a hyperbola is like this. It's going to look something like this. So once again, center is at hk. This is x minus 0 squared and y minus 0 squared. So the center of a hyperbola is such, we call this distance here between this point, and again, these are the vertices of a hyperbola. And the b value is a guide, so the b value goes up here, b and negative b. This is a and negative a. And we can draw a little box. What we're going to do eventually is draw a little rectangle as a guide to draw the hyperbola. We'll get into that more. But the a value tells you, in this case, if it's under the x, then the hyperbola looks like this. If the a value is under the y, okay, if we're looking at something like this, here notice the y fraction is the positive and the x fraction is the negative. The a value always goes under the positive. It doesn't have to be larger like it was for the ellipse. Remember, the a value was always the larger number in the denominator. That's not the case here with hyperbolas. The a value always is associated with the positive fraction. This one is the other direction. It's going to look like this. Again, the center at the origin. This value here is the a. This value out here where the b values are going to be in this direction. And the hyperbola is going to look like that. So same couple of questions. Given an equation of a hyperbola, be able to draw the graph. Given some information about a hyperbola, be able to come up with the equation. So let's look at, and the relationship between a, b, and c here is slightly different. In this case, it is a squared plus b squared for hyperbolas. And again, c gives you the foci, and this time the foci, remember the foci were within the ellipse. The foci points are going to be outside of the hyperbola, right? We call this distance here the transverse axis. So this is the center. This is a values up, negative a values down to get to the tips of the arcs here, the hyperbola shape. The b values are along the minor, what we call the minor axis, I guess. And again, it doesn't have to be, a can be shorter than b in this case. That was not the case with ellipses. And let's look at a couple examples here. So let's take this equation and try to graph it. All right, so this is nicely in the form that we want. We see the positive fraction is the x fraction, the negative fraction is the y fraction. So we know immediately that we're looking at a hyperbola that is along the x-axis. We know the center is at the origin, so we know that center is here. This tells us that a is 5 and b is 4, right? The square root of the value under the positive fraction is the a. The The square root of the value under the negative fraction is the b, and now we use our relationship for the c value plus, so we get c squared is 25 plus 16 or 41, so we get plus and minus the square root of 41. That's going to tell us where the foci points are. And now we have everything we need to graph this hyperbola. We know the center is at 0, 0. We know the transverse axis, the number, the a value under the positive, tells us we're going to go 5 units to the right and 5 units to the left to get the transverse axis. We know it's along the x-axis. Let's leave the graphing. I'm going to show you what the b value does. You can see better pictures of this in the book. But the b value we said was 4, so that's going to go up here and down here. And the foci points, notice this is a number between 6 and 7. Right? The square root of 36 is 6, square root of 49 is 7. So this is somewhere between 6 and 7. This number was 5 and negative 5. So the foci are out here past the endpoints of the transverse axis, right? That's always going to be the case. So what we do, if you want to grab, the way the book describes this, I mean, all we're really doing is drawing, you know, an arc here that goes through 5, and an arc here that goes through negative 5. But just to get into the details a little bit, we said b was 4, so we went up 4 units and down 4 units. Now we can draw a little rectangle between those a and b values, right? So you draw a little rectangle and you get this rectangle, right? We also are interested in the values that are going to give asymptotes to this to give us a guide how to draw it. What we're doing here, the hyperbola looks like this. Center at 0, 0. We'll look at the asymptotes in the next example. And one endpoint of the transverse axis at negative 5, 0. The other at 5, 0. The foci at positive square root of 41, 0. And negative square root of 41, 0. The minor axis points at 4 and negative 4. Okay, and that is what we're trying to do here. Okay, so that was in the x direction. Let's look at one in the y direction. If we were to graph y squared over 25 minus x squared over 16. All right, so all we've done here is switch the signs, right? Now the positive fraction is on the 25. The positive fraction has the 25, and the y, the smaller number, 16, is under the x, the negative fraction. And again, larger and smaller doesn't matter here, right? So this one now is just in the other direction. So we're going to get all the same numbers, right, because we have the same numbers. So we'll quickly go through this one. Center at the origin, instead of going out 5 units along the x-axis, we're now going up and down 5 units. Our c value is up here and down here, and our b values are now over here, b and negative b, and here the a value is 5 again, the b is 4, and our c was plus and minus square root of 41. So instead of being elongated along or going along the x-axis, now we have a hyperbola that looks like this. All right, so just the other direction. Okay, let's look at this, kind of the same things we looked at for ellipses. We want to know about ones that are not centered at the origin. Or let's first look at finding an equation. So let's say we want to find the equation for a hyperbola with foci at 0, negative 5, and 0, 5, and vertices And the vertices, again, are the endpoints of the transverse axis. Vertices at 0, -3, and 0, 3. All right, so let's draw that because that will give us a better idea of what we're looking at. Okay, so 0, -5, and 0, 5. So that's the foci up here at 0, 5 and 0, -5. And the vertices, and again, only two vertices, end of the transverse axis, 0, 3 and 0, -3. And so the foci gives us the C value, and the vertices give us the A value, right, which allow us to find the B value, right, because we know C squared is A squared plus B squared. And we have the C squared is 5 squared, and the A squared is 3 squared. So we end up with 25 minus 9, right? 25 minus 9 is B squared, so we get 16, which tells us that B is 4. Right? So the B value is at 4 and -4. So this was 5, this was 3, and -3, this is 4 and -4. And we know our ellipse is going to look like this. Oh, that was a horrible line, wasn't it? It's going to be something like that and like that. Okay, so we got our vertices 0, 3, 0, -3. We have the foci at 5 and -5. The B values at 4 and -4. And we wanted to find the equation, right? So now we have A, B, and C, so this tells us what the equation is going to be. We know it's along the y-axis, so we know the positive fraction is going to be the y's. So we're using this form. Y squared over A squared minus X squared over B squared equals 1. So now we're just going to plug in the A and the B here. The A is 3, the B was 4. So we get Y squared over A squared minus X squared over B squared equals 1. All right, so again, notice the A value was less than the B value, which never occurred with the ellipses, right? But that's possible when we're talking about hyperbolas. All right, what else we got? So we want to talk about asymptotes, just briefly. And you'll see this in the book, Asymptotes for Hyperbolas. And this is a guide to drawing. So remember I looked at it earlier a bit. But what we want to say here is, let's just take an example of a hyperbola that looks like this. We know this was the transverse axis at -A and A. And we said the B value was the other sides, right? And we drew this little rectangle to get that box. So the asymptotes, when we have this equation, x squared over a squared, y squared over b squared equals 1. So remember, that's the case. Positive fraction is x, so that's when it looks like this. The asymptotes, which are going to be the lines that go through the corners of this box. Okay, so the line that goes here and the line that goes here are the asymptotes. And remember what an asymptote is. It's a line that a graph approaches but never reaches. So in the book you'll see they use this as a guide to drawing these curves. Okay, so this curve, this asymptote going through the diagonally through that rectangle that we draw, acts as an asymptote for this edge of the curve. This will get closer and closer to this line, but never reach it. Same thing down here, this will get closer and closer to this line, but never reach it. Same thing on this side. So you use it as a guide to draw. All I'll be concerned with is that you're able to come up with the equations of these lines, which are pretty simple. In this case, the asymptotes are going to be at. And we're just using a slope-intercept form, and it doesn't even have a y-intercept because 0 is, well, it has a y-intercept, but they're both 0. Right? So that's why you're not going to see in the mx plus b form of the equation, the b is going to be 0. So here we're going to get and negative. Okay, so when we're looking at this, the equation of this line, notice it has a positive slope. It's rising from left to right. That's going to be this value. And in this case, well, we don't have any letters here, but this is the case where the asymptote is the positive value times x. And in this case is going to be the negative value times x. So I just want you to be able to come up with that equation. And once you have the information for the hyperbola, you're going to know what a is and what b is, and you're going to be able to come up with the equation of that line. More importantly is finding the a, the b, and the c's. Remember, the c's are going to be outside here, c and negative c. And then you'll be able to draw the graph. You don't need to use the asymptotes as a guide, but I want you to be able to come up with the equations of the asymptotes if necessary. So 2 cases again. We said this is the case where the hyperbola is along the x-axis, and then we have the other case where the hyperbola is along the y-axis. And in that case, the asymptotes just take the reciprocal of this fraction, we get plus and minus a over b times x. Right? So plus and minus, instead of b over a, it's a over b. All right, so just be able to come up with the equations for those asymptotes. Okay, let's see. One more thing here, again, just like in the last section, sometimes we have to do a little bit of work to get the equation into the standard form so that we can graph it or look at it in whatever way we wish to. So something like this, if you're asked to graph this equation. All right, so we're told this is a hyperbola, but it's not in the form that we want. Again, we need a 1 over here, so we need to divide both sides by 4 to put it into standard form. So this is a hyperbola, but it's not in standard form, the original equation. So we divide things by 4, we get y squared over 4 minus x squared over 1 equals 1. And we put the 1 down there just so we can see the standard form. And now we say, okay, this is positive fraction is the y fraction, so the a value is the square root of this number, the b value is the square root of this number. So we know a is plus and minus the square root of 4, and b is plus and minus the square root of 1. So we know what c is, a squared plus b squared. So we get 4 plus 1, which gives us a c squared of 5. And that allows us to see where those c values are. And then if we're asked to graph this, we know it's centered at the origin, right? Y minus k, x minus h. That's going to be where the center is. In this case, centered at the origin. And let's see, positive on the y, so we know it's along the y-axis with a value of 2, so we're going up 2 and down 2. B value is 1, so we got a 1 over here, negative 1 over here. Draw that little box just to practice asymptotes. All right, the c value is square root of 5, so it's a little bit more than the 2. So c value up here and another c value down here for the foci. The asymptotes. And we're looking at this case. So plus and minus a over b times x. So we get a is 2, b is 1, so plus and minus 2x. So y equals 2x is one of the asymptotes. Y equals negative 2x is the other asymptote. So this one has the positive slope, so that's 2x. This one has the negative slope, so that's negative 2x. All right, so again, that just gives you a guide for drawing the curves. So these act as asymptotes. We know it's in the y direction, so we're looking at something like this, right? Approaching those lines but never reaching them. Same thing here, looking something like that. You want to label your center. You want to label your vertices. You want to label your foci. You want to label your B's. 1. You want to label your asymptotes. You want to draw it as best you can. All right, let's do one translation. So this is one that's not going to have a center at the origin, just like we did for the ellipses. We want to be able to translate up, down, left, and right here. And for translations, there's also a nice table to look at on page 680. All right, so just like the ellipses, instead of just x, we say x minus h squared and y minus k. And again, depending on which fraction is positive, that's going to tell you where to put the a value, right? If this was the positive fraction, then the a goes under the y. Positive fraction, x here, goes under the x. Okay, so we want to look at an example of this. Let's look at this one. So we want to graph this hyperbola. All right, so nicely this is in the form that we want. We have the 1 on the right-hand side. If it's not equal to 1, we got to make sure we change that to a 1. Here we can see the center. The positive fraction is the x fraction, so we know it's along the x-axis. The a value is square root of 4. The b value is square root of 1. So we get the same c value that we got before here. We can say the center is at 3, 1, positive 3, positive 1. Our a value is 2, our b value is 1, so we find the c value just like we did in the previous example, and we get plus and minus square root of 5. Okay. A squared 4 plus 1 squared 1 gives us 5, square root of 5 gives us the c value. All right, so what this, all we did now is shifted a few units from the origin. The center was at 0, 0, the previous examples. Now our center is at 3, 1. All right, so 1, 2, 3, 1. There's our center of our hyperbola. Positive fraction was the x's, so it's going along the x-axis. So this is 3. We're going to go out to 5 and back to 1 to get the ends of the transverse axis. And we'll label them at the end. The b value is 1, so from 1 we're going to go up to 2 to find the endpoints from 1 up to 2 and down to 0. So that's where we're going to draw our little box. And the asymptotes are going to go through the center of that box. This one's the positive, and we said the asymptote here. We have our A, we have our B, we have our C. So we know this is again along the x-axis. Our asymptotes act as guides. So we're going there. And approaching this line, never reaching it. Approaching that line, never reaching it. And same thing over here. You want to label the center. You said was 3, 1. You want to label the B values. You want to label the ends of the transverse axes. So this is at 5, 1 and 1, 1. And remember we said the asymptotes are plus and minus B over A times X. Oh, but also be careful here when it's not centered at the origin. We got to put that y minus k equals plus and minus, in this case, b over a, right, for this direction, and the x minus h. So we know our hk was 3, 1, right? This is the hk, the center. So y minus 1 equals plus and minus b over a times x minus h. That's where the asymptotes are going to be. So plus is this one, the positive slope, and the negative is this one, the negative slope. All right, good times, huh? Hyperbolas. Foci, we did the foci. Oh, we didn't do the foci. The foci is out here. Foci is going to be at 3 and 3 plus root 5, 1 foci. And over here, 3 minus root 5, 1 is the other foci. All right, the C's. Put it over here, I guess. All right, so the A value, the B value, the C value, these are the important things. Being able to come up with the equations for the asymptotes and getting somewhat of a graph of the hyperbola. Okay. That's it for 7-2.